Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Magic Square in a Grid. Okay, so a 3 cross 3 Magic Square is a 3 cross 3 grid filled with distinct numbers from 1 to 9, such that each of the row and the column both have row, column, and both diagonal sums are equal. Okay, so each row sum up to a certain let's try to understand what the problem statement is saying here. So let's take one of these examples to understand. For example, this square is a magic square. You can see the row sum and the column sum for every column and every row, and the two diagonals are equal. Okay, so 4 plus 3 plus 8. Okay, and it is also equal to this. Okay, so every row will be having equal sum. Okay, and you can see that these diagonals are also having the same sum. Okay, these two diagonals, let's change the color here. So these two diagonals are also having the same sum. So this is what the problem statement is saying, and the columns will also be having the same sum. So 3 plus 5 plus 7. Okay, so all of these are having same sums. Okay, so this is a magic square and the other one is not. Okay, so you can check these examples and you will be able to understand what it mean by row, column, and both diagonals have same sum. Okay, so given a row into column dimension grid, you have two of integers and written how many 3 cross 3 contiguous magic squares can be subgrid of this grid that will be given to you. Okay, so you have to count the number of magic squares in the given grid, okay, of 3 cross 3, and these are the conditions that should be fulfilled. The first one is that all the numbers from 1 to 9 should be distinct, and there is a note also at the end of the statement. We will discuss that in a bit. So all the numbers from 1 to 9 should be distinct in the given subgrid, and each row, column, and the two diagonals should be having the same sum. Okay, so this is the necessary condition, and there is a note that while a magic square can only contain numbers from 1 to 9. Okay, so numbers from 1 to 9 are only allowed, that is already mentioned in the previous statement, but then it says that grid may also contain numbers up to 15. So I think till now it's clear to you. Now let's have a look at the constraints. So before thinking of an approach, it's better to have a look at the constraints. So the number of rows in the grid will be of, and the columns will be of order 10. Okay, so it's a pretty, the constraints are not that hard or not that strict here. So it will be easier to implement just a brute force approach. By looking at the constraints, we can say that. Okay, and each entry is ranging from 0 to 15, but we are only interested in the values from 1 to 9 in our subgrid, and otherwise if any other entry is present, we will not consider that as a magic square. That subgrid will not be considered as a magic square. So let's see how we can solve this particular problem. So since the constraints here were less, and there is a operation limit for the number of operations that till which if the number of operations are when within the range that your solution is performing to get to the answer, then it's fine and it will get accepted, and that range is 10 raised to power 8 operations. So if the number of operations required by your program are less than that, then you will get accepted solution. Okay, and as we discussed, the number of rows and columns, the order of rows and columns is 10, both 10. So if you even take all the possible starting points of the grid, what do I mean by starting points? So what you will do, you will consider each coordinate or cell to be the topmost, top uh, top left, you can say, corner of the subgrid. So what I am trying to say is, let's change the example here. So let's delete it and bring a new example, or let's take a fresh slide itself. I think that will be a better thing to do. So let's take this one. Okay, I hope it's visible enough. And what we will be doing is, since we were trying to take every cell as the leftmost, top left cell of the grid of size 3 cross 3, so we are saying that, so we are considering this 4 as the left corner. Okay, next time you can consider 3, okay, as the top left corner. Okay, but it should be kept in mind that this grid that you will be forming from this top left corner should be well within the boundaries of the, this subgrid that you will be forming should be well within the boundaries of the original grid that is given to you. It should not be the case that you are taking this as the top left and you are going outside the boundaries and there is nothing outside here to form a 3 cross 3 grid, subgrid, to be specific. Okay, so this should be kept in mind. Other than that, we will just do a brute force, and when we are doing this brute force, then you will simply check whether each of these cells being considered at the as the top left corner of the subgrid fulfills dot condition or not. Okay, fulfills magic square condition. Okay, so if it fulfills the magic square condition, the condition being that the numbers from 1 to 9 are only allowed, and each entry in the subgrid should be distinct. Okay, distinct numbers, and each row, column, and both of the diagonals should be having equal sum. Okay, if these conditions are met, then we will say that the current subgrid that you are considering is a uh, magic square. Okay, so let's see how we have implemented that. Okay, so it's just now a implementation problem after this particular observation. Okay, so let's bring the implementation to the board and try to see how we have achieved this. Let me adjust it a little bit. I think now this should be visible enough, and let's remove the toolbar also. Okay, so let's discuss what's happening inside the code. So what is happening here is, first of all, you will be checking every cell, every uh, possible candidate, or you can say every cell. Basically you will be checking only those cells which are feasible, since the grid was having a size of subgrid was having a size of 3, so that's why we are doing this. Okay, because you can take up to a certain extent only. Okay, so if you want to have a subgrid, then you can, this will be the last subgrid. After, if you want to consider after 3, then it cannot be. Okay, so that's why number of rows are here 4, and number of columns, number of rows actually are 3, sorry, and columns are 4. So columns minus 2 will be 2. So if you go with the indices, okay, so it will be this. So your index that you will be considering in the columns area will be lesser than this 2. Okay, similarly it will be lesser than 1. Okay, so in the row, so in the row we are already having r at lesser than 1, we cannot go beyond this. Okay, so it is not allowed. So that's why those two constraints are there. Okay, and every cell will be considered as top left corner, okay, of grid. So this is what you will consider, and then you will have a check whether this the subgrid that we are considering, starting from the current cell, which having the current cell as the top left corner, is a valid magic square or not, whether it satisfies those conditions. So those conditions were that every number in the grid should be from 1 to 9 and it should be unique number. Okay, so for checking the uniqueness we are using this array. Okay, so since there are only numbers from 1 to 9, so a 9 size array would be sufficient. And keep in mind that the array is using 0 based indexing, so you have to subtract 1 from the actual value and then check. Okay, so this is for checking that whether we have seen this value before or not in the grid, basically to check the distinct property, okay, of all the values in the grid. Okay, and you will check all the current values in the subgrid. Okay, and if a value is not within the range of 1 to 9, then you will return false. Also, if it is already seen, then you will return false. Okay, but if that's not the case, then you will say that okay, we have encountered this value for the very first time, and you will keep on doing this check. Okay, so once you are completed with this particular section, you will be ensuring these two things, distinct numbers from 1 to 9, okay, in the subgrid. So now comes the second part, that row sum and column sum should be equal, okay, for each row and column. So what we have done here is we have taken a sample row sum, okay, for of the first row. Okay, for the you can say, yeah, it is the first row, from top left to top right. Okay, so for the first column you are considering the sum. Okay, once you are having the sum, then you will compare it to the rest of the column sums and row sums. Okay, so and I have made the code as much as verbose as possible, so I think you should be able to follow. These increments are just to iterate over the current subgrid. Okay, so that's why this logic is here. So you are just incrementing the row numbers by using these increments. Okay, so then row sum and column sum will be initialized. Okay, and you are checking for the current row this uh, row number. Which row number we are checking for? We are checking for this row number. Okay, so and then we will check for the current column number, which is this column number. Okay, so if at any point the current column or the current row is not equal to the sample sum that we have already taken, then you will say the condition is being violated and we should be returning false, that this is not a magic square. Otherwise we are fine, and we will proceed with the further checks. Then comes the checks for the diagonals. Okay, so this is the diagonal of this particular orientation. Okay, so this is this diagonal, and this is the diagonal of this particular orientation. So as you can see here, both of the values of row and column are being constantly increased, so you will be going down this direction. But and starting from here, okay, but in the other one you are starting from here and going down this direction. Okay, so this is what is essentially happening here. Okay, and yeah, that's pretty much it. Then if the diagonal sums are not violating any property, that they are not equal to the sample sum, then you will say that okay, this is a magic square and we can count it towards a magic square, the current square. Okay, so the current square will be counted towards a magic square here. Okay, it's just a brute force approach, and you will return the number of magic squares. Okay, and let's have a quick discussion about the complexities also. So time complexity wise, it will be order of number of rows into columns. Okay, and space complexity wise, it will be constant, since we are not using any extra space here. And these loops are running for just, as you can see, 3 into 3. Okay, order of 3 into 3, you can say. Similarly, this one also. Okay, everything here is running in that order. This is order of 3 into 3, and this one is only running for 3 times. So it is irrespective of the fact what kind of size we are dealing with. So you can say the overall time complexity can be approximated to number of rows into columns, and space complexity is 1, since we are not using any extra space here. Okay, so I hope everything is clear to you. If you are still having any doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And I will see you in the next video. Until next time, keep solving more and more problems. And thank you for watching.